This is René Descartes, French guy, super genius, lived back around the 1600s. Now, at this time in history, if you had a lot of money and you had access to the upper echelons of society, you were one of the only people who were allowed to go to school. Basically, if you were a rich, white guy, you could get educated. Everybody else, don't worry about it. René Descartes learned everything in school, and he's known for a lot of different things. He's known in literature, he's known in science, but the two things that he's still famous for primarily are philosophy and math. As far as philosophy goes, his most famous quotation is cogito ergo sum. That's Latin for I think, therefore I am. And if you haven't encountered that statement before, you'll certainly run across it again in high school and college. As far as math goes, he's primarily known for noticing a fly on his ceiling. See, the story is that he woke up one morning, opened his eyes, looked up at his white ceiling, and noticed that there was a black fly there. And he thought, the words that I would describe the location of that black fly are to the right of that light fixture, and then down a little bit. Then he got up out of bed, went to the other side of the room, looked up at the ceiling, fly was still there. Fly was still in the exact same position. But this time he realized that to describe where the fly was located, he would have to use different words. He would have to say, well, that fly is to the left of the light fixture and up. The exact opposite description that he had used when he was 10 feet across the room. He thought, that's really weird. That fly is in the exact same position, yet the words I would use to describe where it is have changed. That doesn't make any sense. If it hasn't moved, we should be able to use the exact same terms to describe where it is. Doesn't matter whether I'm laying in bed, or over here by the door, or in the room across the hall, or in Indonesia, or on Mars. If a thing hasn't moved, there should be a consistent set of words we use in order to describe where it's located. No matter where we are, when we look at it, we should be able to describe its location using the same terms. This is called absolute position. And it led to the development of a thing named after him. Remember, his name was René Descartes. It's called the Cartesian graph. And it involves two number lines, one going left to right, one going up and down. We know how to use number lines. We did that in 6th grade. The one going left to right is called the x-axis. Axis is a fancy word in this case for line. You can remember that left to right that the x-axis goes left to right because an X kind of looks like a cross. And the x-axis goes across the page. The other one, going up and down, is called the y-axis. Way you might remember that one is that y goes to the sky. Cheesy, I know, but trust me, it works. If we want to locate a position on the x-axis, we just drop a dot. We have a dot now at 1 on the x-axis. We would call this an x-coordinate of 1. If we want to give a location on the y-axis, we drop a dot. In this case, we have a y-coordinate of 2. Now, you put those two things together so that they cross at the zeros like a plus sign. Now you've got yourself a Cartesian graph, and you can use it to describe the exact location of a point. The way you do that is you have two numbers inside parentheses separated by a comma. The first number is how far you have moved from the middle, left or right. The second number is how far you've moved up and down from the center. It's important that you always put these inside parentheses with a comma in between the numbers because if you don't, it means something else mathematically. All right, let's try to plot a point on a Cartesian graph. Remember, the first number is where we go left to right, the x-coordinate, how far we move on the x-axis. In this case, it's 1, so we take 1 step in the positive direction. In this case, that's to the right. Our second number, the y-coordinate, is how far we move up and down. In this case, we're going to say we move to positive 2. 2 steps in the positive direction. In this case, that's up. Then we drop a dot. That dot right there is at the location 1, 2, because it's 1 step to the right on the x-axis and 2 steps up on the y-axis. Let's find another one. This is a lot cleaner of a Cartesian grid, and the thing you're going to see a lot over the next couple of weeks. Remember, you have to put the numbers in parentheses separated by a comma. What if we want to have the position -3 for the x-axis? Remember, the first number is how far you move left and right. So in this case, we want to move 3 steps in the negative direction. That would go to there. Our second number is -2. The second number, your y-coordinate, is how many steps you want to take up and down. In this case, we want to go 2 steps in the negative direction. That would be 2 steps down. Drop a dot. This point is located at -3, -2. Let's do another example. +4, +5. Where do you think that would be located on this grid? The first number, +4, is how we move left and right along the x-axis. It's the x-coordinate. Since it's positive and we're moving left to right, we want to move 4 steps in the positive direction. The second number, +5, is our y-coordinate. In this case, we want to move 5 steps in the positive direction up and down. That means we drop a dot right there. 4 steps in the positive on our x-axis and 5 steps to the positive on our y-axis. Another example, 2, -4. Well, the first number is our left to right number, our x-coordinate. Since it's positive, we're going to take 2 steps in the positive direction. The second number is -4. That's our y-coordinate, up and down. This number tells us we should take 4 steps in the negative direction. Drop a dot, and that point is at 2, -4. What about this orange star? It's actually sitting on top of the y-axis, but it's up 3 steps from the center. How do we notate that? That would be at 0, 3. That first number is 0 because if we start at the center, we haven't taken any steps at all to the left or to the right. We've stayed in the middle as far as x is concerned. Second number is 3 because as far as up and down goes, our y-coordinate, we haven't stayed still. We've moved up 3 steps in the positive direction. So 0, 3 is going to end up sitting on top of the y-axis because we haven't moved left or right, but we have moved up. How about this guy? Purple. Notice he's sitting on top of the x-axis. What would that be? That would be 5, 0. Because we haven't made any moves up or down. That's what that second number means. We've taken 0 steps in any direction, up or down. So the second number, up or down, y, is 0. We have taken 5 steps in the positive direction as far as moving to the right or left. That's why this is +5. So in this case, 5, 0 ends up sitting on top of the x-axis over here. That's a Cartesian grid. Your assignment for the day is to complete the homework in your OneNote folder about Cartesian graphs. If you have any questions, I will be in office hours starting at 1:30. Have a good afternoon. Bye.